Oh, it is the most consequential work I have done in my entire career.
As an engineer, I take a lot of pride in solving problems. Our goal is reducing ignitions and maintaining reliability. PG&E's distribution network is high voltage. There's a lot of energy present.
A man in protective gear working on a substation.
We are talking about thousands of amps, thousands and thousands of volts. The moment it becomes a real electrical arc,
A tree branch sitting on top of two power lines, sparking and catching fire.
we trip the circuit. That is the main objective of EPSS, which is Enhanced Powerline Safety Settings.
When there's a fault, there's a device that sends a signal to de-energize the line.
A monitor screen displaying a fallen branch, sitting on two power lines, that causes an electrical arc.
There's some energy released, so the intent of EPSS is to minimize that energy that's released.
Two men walking in front of a domed building, as a title displays Enhanced Powerline Safety Settings Tests, San Ramon, California.
So the testing we've been doing involves ignition testing. One thing we'll do is we'll purchase sod. The sod will be dried to a specific moisture content, and we can run tests on it afterwards. The sod we have here, it hasn't been dried yet. We'll also collect vegetation, and the intent there is we're experimenting with different fuel medias in our tests.
A man looking through different types of cut tree branches.
The way I look at it, a lot of the problems today, we have people solving them today. But a lot of the work we do here is actually solving tomorrow's problems before they happen.
So we'll start out with this one here. We'll find the sweet spot and then it'll just drop on like that.
A man holding a tree branch and visually explaining how it will be dropped.
We are up against Mother Nature, and we all as an industry realize that wildfire is a greater risk than anything else we are facing, and that is our focus.
Maybe up a little bit. I just hope it lands right, dude.
Test drop!
A man in a boom lift dropping a tree branch on top of two power lines.
Out in the field, we have electrical faults, and the most common faults are phase to phase or line to line, or a second type of fault is phase to ground. That's where either a conductor could touch the ground or another object that's grounded.
The conditions that are abnormal in real life, we have the ability to create them in our lab.
Okay, Jose, green, green, red, green.
Green, green, red, green.
Close 272.
Two men in an office interact with switches on a control panel.
272 is closed. Bank is energized.
All right, dropping tree limb.
When the branch comes in contact with high voltage, high power lines, what happens is it contacts 2 points.
Two screens display a side-by-side comparison of a branch falling onto power lines. One screen says EPSS settings enabled and displays a slight electrical reaction, while the other screen says EPSS settings disabled and displays a huge electrical arc that travels up the power lines.
And from there, it begins to start carbonizing, and that creates a conductive path between the 2 points, creating the flashover.
A branch on top of power lines has a small explosion preceded by an electrical arc.
The protection settings for something to get detected, get a signal to the device that's gonna act on that sensing, and then disconnecting the power to the line. All of it happens within 100 milliseconds.
They can't be so quick that a momentary load bump would de-energize the line. And they can't be so slow that a fault persists for a period of time and there's a lot of energy released, which can lead to undesirable outcomes.
That's the sweet spot.
Two screens display a side-by-side comparison of an energized line falling onto vegetation. One screen says EPSS settings enabled and displays a small explosion and sparks, while the other screen says EPSS settings disabled and displays a huge explosion, many more sparks, and catching vegetation on fire.
that we are trying to find, because you cannot trip the power for every little thing, only if it is necessary. Our focus is putting brakes on those events before they become catastrophic.